Alright, in this video we're going to talk about Fulcro's indexes. You don't use these often, but if you understand them, you'll understand everything there is to know about writing your own renderer for Fulcro. So I guess there's two purposes for this video: to kind of talk about the rendering of Fulcro and how it works, how the different plugin optimized renderers work and what they can leverage in order to do their optimizations. And some interesting things come out of this Fulcro model of having co-located queries, idents, and local, initial state, and even component local state. Haven't talked much about component local state in really any videos to date, but I'm going to talk about it here. So what are Fulcro's indexes and how do they help with rendering optimizations? So let's just talk about what they are. Fulcro's indexes are nothing less than an index of every on-screen component. That's one index. There's an index that tracks per keyword that's queried which classes query for it. So for example, I can ask an index who queries for counter count, and it'll tell me, oh, well, the counter component does. I'll show you that in a minute. I can ask for all of the on-screen components that have a particular ident. So, and those actually give me the React elements. So we saw in the last video when we were looking at the internals of the defsc macro and what it actually does. Let's pop back into that. Be easier probably just to jump to defsc and go to defsc star and then look at configure component, and then we can see configure component does this whole mess of rewriting. And you'll remember that when we were looking at component did mount, there was this wrapper function that was pulling out the definition of the index component. The indexes are actually a pluggable thing too, but I kind of just made everything pluggable in Fulcro 3. I can't even think of a reason why you'd, well, I can think of reasons why you might want to change the implementation of this algorithm, but they're not very good reasons. But this index component call happens every time a component mounts, and this is done both in hooks-based components and non-hook based components. So in Fulcro, when you say use hooks, you don't just get a plain function, you actually do get an augmented function that registers effects and state, because there's another element that we use as part of rendering optimization that has to do with these additional tweaks that we do to Fulcro components. So Fulcro components, even when using hooks, are not plain things. So if we go look at the configure hooks components, you'll see, and you saw this in the last video, that when we add the hook options, add hook options, is that where it's at? That's not where it's at. Well, it's pretty easy to find if we just do that. Here's where it is. Yeah, sorry, there's a use Fulcro effect that's used by the hook. And you see it does this use state here, which creates kind of a faux component local state, because there's some Fulcro calls like set state that you still want to be able to use with these. I want to be able to use. You'll see in a minute what I mean. And there's also this use effect that indexes the component and drops the component as a hooks-based side effect. So same thing, index component, and then the cleanup routine is drop component. And then the only thing that causes this to change what its index is if the component's ident changes. And you'll see why that is in a minute as well. So this is the other element of things that are happening inside of a defsc component. It's mainly just React rendering and giving you some nice syntactic helps for building these. But there's this indexing thing that happens. There's a couple of other things having to do with component local state that we actually play with to enable some interesting optimizations. So let's look at what those are. So that's the basic idea of what we're looking at. Okay, so we've got a simple app here. I started out with this one yesterday and then didn't really even use it much, but we've got 4 counters. If you click on them, they each have their own instance. If you go and look at them in Fulcro inspect, that window's way too small to even see them in there, but they each have their respective state and ID. And of course, when you click on them, the state changes. Big surprise. Okay. So that's what we got as our simple app, and that's enough to show you pretty much everything I'm going to show you in the video. I've set up init local state so that there's a color. So this is component local state. This is application initial database state. And with init local state, when this thing mounts, it's going to have color named positive, and in semantic UI there's a positive, there's a negative, there's some other kinds of things that you can throw into a button to change its color based on the theme that you've themed your CSS with. So if you say UI positive button or UI button positive, you'll get a green button normally, or by default, like the default layout, if you say negative, you'll get, I think, a red button. And I'm just using the classes augment, and this is an augment that's built into Fulcro's DOM macros, where you can list a vector of strings and it'll throw them into the class name along with these. And so yeah, if we go and like inspect one of these guys, oops, not view page source, you'll see UI button, and then there's a little extra space there and positive. And you can actually throw nils into this, so you can put like a win and that sort of thing in here, and the nils will just be ignored. So this is a, you know, I could put in big in here, and then we'd have UI big positive buttons, etc. So anyway, it's just a way of doing things that are often kind of computed classes that you want to tack into the class name that co-locates. Anyway, that's all they are. And I'm getting this from component local state, so I can show you ways we can play with indexes and mess with component local state. So root queries for counters. The counters have IDs. The idents of these, as you saw a minute ago, and as you could guess, based on the ID parameter, the initial state of that guy will make that ID parameter the counter's ID. Parameter start will make the counters count start at that. And so let's just go ahead and reload this, and we'll see those numbers there. Great and wonderful. Okay, let's play with indexes. So down in here, our comment block, I've already written some things, and so let's just look at these individual pieces here. So let's pop this guy out and just run it. So this function in the components namespace of Fulcro can take an ident and return all of the on-screen components that currently have that ident. And so you see I get a React component there in a set. So if I had more than one component on the screen that rendered that, say you have a list of people in a master detail view and there's a person form, both the row 1 might have person ID 1, and if you're editing person ID 1, the form might have person ID 1 as its ident. So that's a set of things that you could find on screen. There's also this ident any, and I'll run the sub expression out of this, and you see that gives me back just a single one. It's not a set, it's a single one. This one is basically, if you're pretty sure you only have one on screen, that's kind of the quick and easy way of getting it, as opposed to just saying first and that. So let's grab that guy and see what he is. So I can call get ident on it. I can call props on it and see what the last props were passed to it. So if I go up here and click the guy, I can see, oh, well, what are the props you got last? Oh, I got ID 105. Great. I can find out what his parent is and what the React type of his parent is. Oh, it's root. Right, so you can kind of explore the tree just by pulling these guys. And notice this is a data-driven way to find things on the screen. So this is why it's useful for things like optimizations. If I want to do a targeted render or re-render of something, being able to look it up by what it talks about is an interesting thing. So let's talk about the other important index. There's an index of prop to classes, and this one, well, here, let me show you. If I say I want to find what class queries for counter count, that tells me counters query for that. Notice this is a keyword, and the reason for this has to do with hot code reload. The indexes, if the indexes were to close over the actual classes and then you hot code reloaded, you could actually have something in the index that was stale and didn't match the thing. So we actually use the registry, which does get updated on hot code reload, to look those up. So if I were to look up the classes that are given prop queries, I'd then have to run them through a map of registry to class to get the real live in code component class that's currently being used for that thing. And then if I know what class I'm looking for, I can find all the on-screen instances. And notice here I'm using the actual class, so it would be the return value of this guy. I can find all of the on-screen components that implement that class. So let's say what you're trying to do is I want to, let's say, maybe you've got other components in the system that query for things. So I'm going to put counter count down here, even though root isn't a counter. I'm going to force reload that because I think the root index doesn't get updated on hot code reload. And I'm going to say find all the classes, and now you see root is in that index. So those of you who've been around Fulcro for a while remember the ident optimized render, and that in transactions you also had to do what were called Followon reads, where you would come up in your transaction, you'd say, oh, you know what, I want you to update everything that queries for counter count. That was actually a built-in thing that we inherited from an omnext idea. In omnext, the idea was, well, we don't want to render from root necessarily all the time because that might be expensive. What we'd rather do is have you tell us via data what data you changed, or what kind of data you changed, and we'll go and look up all the things on the screen that use that data and refresh it. And over time, I was analyzing the performance of these various ways of doing these optimizations, and not only was this very error prone, I mean, I eventually moved it into, in Fulcro 2, you could say refresh at this level, right, at the mutation itself, because this is where you're changing things. You say, oh, well, I changed counter count, and I changed whatever else you changed, right? Here we're only changing counter count. And so you could list it here, and that would be sort of an instruction to the optimized render. So Fulcro 2 only had one way of doing render. It was kind of fixed. And so I kept trying to find ways of making it easier so that you didn't have to say, oh, I'll call increment, which is supposed to be some abstract mutation that you just happen to know. Oh, I also need you to know that you should re-render things that query for that. I mean, the default in both omnext and earlier versions of Fulcro was that it would always re-render the thing you transacted from. So if you were just modifying things that were local to you, well, you didn't have to say this. This only came up when, oh, well, I know you're going to re-render me, but my parent has a sum of all the counts. Which is a totally legal thing for it to do. So reduce over plus. Something like that. Okay, so 187 is the total. And in other versions of Fulcro, you'd click on this and this number wouldn't have changed because it's the parent. And depending on which renderer you use in Fulcro 3, that can still be the case. And so the fix was to say, oh, well, I want you to also re-render things that query for counters. And the way this was implemented was with the indexes. Right? The transaction system, the underlying Fulcro system, would see, oh, all right, you want to run that mutation. Oh, and it also looks like you want me to add this to the list of things to refresh, counters. So I'll go and I'll run this prop to classes on counters. That'll tell me root. I'll go look up root in the registry and find the actual class. Then I'll go and pass that class into this thing, and that'll tell me all the instances, and I'll figure out what props to pass to that guy and refresh him. Now, note there's an interesting catch here. In order to refresh something out of a relational context, if you remember back in the first couple of videos in this series, we talked about how queries in a component are relational, right? This counter ID and counter count, whose counter ID, whose counter count? Well, the parent supplies that, right? The parent says render this one, then that one, then the other one, and passes a map. So this query is no kind of absolute query. So how would I go about refreshing this specific counter? Well, I can only do that if it has an ident, because if it has an ident, I can ask the component. So let's go back here and regrab counter 1. Or for that matter, let's grab this guy, and we're going to find this fails because root has no ident, right? So, oh, sorry. Right, we want to find all the things that are of type root, and let's just get the first one. And this is going to give me nil because root doesn't have an ident. But if we're a counter, I'm going to find one that actually has an ident, right? And I know there are 4 of those. Right, so how do I get the props for that counter? Well, I know it's class, and I know it's instance, right? So let's say I grab one of them. I want to refresh counter 1. There's C. I can get his ident. I can get his class type, right? Because I can say what is the React type of C. I can ask for the current query, and this actually requires at runtime the current state map. I can ask for the query of that guy. Well, if I know his ident and I know his query, well, I can wrap it in a map and make the query. And if I can make that query, I can run db to tree on it, which we saw in earlier videos, etc. I can get its props. Now the problem is, how do I get the props to it, right? Because the props are normally passed by the parent, right? Root normally gets the props, pulls them apart, and passes them through React props. Okay, this is a little bit of a problem. How do we get it to it? And so the method that was invented, the original method was very similar to what I'm still doing. I call it props tunneling. So with props tunneling, what I do is I leverage the fact, actually I think the original on next implementation was a force re-render where you gave that thing props, but then the React doc sort of said you really shouldn't do that. Like, I don't know, there's a whole mess. So if you look at set state takes a React component. It takes a this. Well, I have that. I indexed it. And I can pass things to that. So I could say set state on C and make it negative, right? I just changed the component local state of that particular thing. So there's first interesting use of having these in the index. I can find component with an ID, right? I just did that guy. I can get his real React instance out of the index, and I can change his state. Well, now think about state. That's a ClojureScript map. You saw in the last video, well, props are a JavaScript thing. So is state. State's a JavaScript object. That means I'm doing the same trick to state that I'm doing to props. I'm sort of putting Fulcro specific things on state to trap the ClojureScript thing, and the low-level state is actually a JavaScript object. And because it's a JavaScript object, all the other keys on it are hidden for normal uses, right? When you say, give me the state for color, if you go and look at this, this actually gets the low-level JavaScript object and looks for Fulcro state on it. So any other keys I want to put on here, I can put on here, and they're sort of hidden to the Fulcro component's kind of high-level use. Which means I can put other things on there, like alternate props. So here's the idea. And this is kind of fun. This is a kind of a Frankensteinian creation, but it works really well. So I've just shown you that I can index the things by hacking into the component lifecycle, whether it be hooks or not hooks, and capture these things into an index. I can then look them up by data path. Now notice that's a Fulcro specific thing. I'm not aware, I mean, maybe Apollo has this, but I don't think it does. I don't know of any other library that's doing this that has a data-centric index to on-screen things. I want to find a person form with ident blah, you can find that with the indexes. And it's the actual on-screen element that you can then call set state on and send it state it actually knows about, or you can tinker with the lower level React state that's there and do other interesting things. And so that's what we do. So this is the tunnel props function. This is a public function, you can call it, although you need to understand what's going on to really use it properly. So if you look at the destructured props for anything in Fulcro, so I'm just going to do a JS console.log of props here, and then we'll see up in the console the props pop out. Make this a little bigger. Okay, count. But if we look at, I'm hoping this is right, it should be. was too small. There we go. The metadata on the props has this special thing on it called denormalize time. And this is the trick. This is the trick to making this work right. So this denormalize time is actually added by db to tree. And so, if you don't know db to tree, go back and review the earlier videos. This is in the Fulcro denormalize namespace. Let's make sure we got that on the class path, or on the required path here. Oh, we already did. And if you go look at db to tree, it calls denormalize, and then it says with time. And if you look inside of denormalize, as it does its recursive kind of processing of the query and the state, it's always adding this metadata at each level, at each join. At each join it adds a time. So what is this time? This time is very much like, if you've used Datomic, it's very much like the transaction time, right? Each transaction is sort of reified. And in Fulcro, in dev mode especially, in dev mode there is actually a history of all the states that have happened. It's limited, right? It gets pruned for inspect to use. So when you're in here in inspect and you see this revision number right here, this is what revision of the database it's currently seeing. And if you click quickly, you see it sticks and it tells you what revision we're waiting on. And the revisions here are actually how many swaps have happened against the state atom, because inspect watches the state atom. Fulcro does not. Fulcro itself does not watch the state atom. It uses the transaction subsystem to decide when to re-render. But inspect, because it wants to show you anything you might have done to the database, it watches the atom so it can catch anything you do to the database. And so it's actually waiting for it to catch up. So this number is not the same number, and there's a function you can call in Fulcro to find out what the app's concept of this time currently is. It's basis t. And so currently the transactional time in the Fulcro app right now is 48, even though the number of swaps that happened against the atom have been 86. Okay, so this basis time is what we end up throwing on the props. So if you go and see this was 48, if I go back to the console log and look at the recent renderings, you'll see denormalized time 48. Okay, so when props come from the root and are passed down through the tree, that means they were generated by db to tree with some particular time. And every time a transaction happens, this time gets updated. So if I click here, right, I can go and look at the denormalized time, where now we went through two things happened, and so 50 is now the number. Okay, so what I'm doing behind the scenes is, if I want to update just this button, if that button has an ident, and I'm running a renderer that has an optimization that says I want to just update the things that changed, I don't want to do the whole from root, what I can do is I can do this function called tunnel props. Now what is tunnel props? It's really quite simple. Tunnel props takes some props, and you have to associate, well, it's not associate a normalized time with that just yet. And it tries to send those props to the given component. So I'm going to make sure this var is up to date so that C is actually that on-screen component. I'm going to try to send the number 91 and counter ID 1 to counter 1, and you see nothing happens. And nothing happens is because props could come to this guy from the parent, or they could come from tunneling. And once they've come from both at least one time, that component's going to have in its component local state some idea of what the tunneled props were, along with their time, and it might see props from the parent. Well, what if the parent was locally refreshed first, and should component update kept the child from refreshing? Well, now the parent's time is newer, and then I tunnel some props, right? You can get these situations where the different times that things have been seen cause confusion. So and I'll show you exactly, like right here, if I send it something that has no time, well, no time is not newer than the time it's seen from the parent, and so it thinks the parent's props that are being passed in are better, and it should use them. So it's actually comparing these. If you go and look at the, that's part of what that whole rendering destructuring thing is doing in the components namespace. If you look at the actual render implementation, it would take me a minute to find it actually, because it's several steps. But I bet if we look for time, well, I'll let you play with it. I don't want to waste our time like scanning for the code. You can just believe me that essentially what I'm doing, oh, I know where it is. Well, we're there. Raw to newest props. So this is looking at the props Fulcro value and the state Fulcro value, and then it's calling newer props. It's saying which of those has the bigger time on it. And so if you look at newer props, it just pulls the denormalization time of each one and figures out which one's newer, and then returns the right set. Right? It looks for nil. Right? If A is nil, then you must want B. If B is nil, then you must want A. If you've got both, you want the newer one. Right? So there are two sources for quote props on a component: props that came from the parent and props that could be tunneled from a customized pluggable renderer, so that it can choose to refresh just the things on screen it wants to refresh. So let me pop back to the app here. Okay, so let me go back to what this said. This said with time 15. Well, I know the current time in the app. Let's make sure hot code reload didn't clear. It did. Cleared my... I'm going to move this outside of the comments so C is always set on hot reloads. So C's there. I look at the basis time of the app. It's 52. I try to send it with 15. It says no. But if I send this with 53, well, now I get it. If I send this with 63, oh, here, let me change the number. Right? I get 98. Now, the prop that's actually in state right now, remember counter 1, if we go and look at that, it's actually 100. And now I've put this time of 63 on there, and I know the app time is really 53. So I'm going to have to click on this button. 1, 2, 3, 4, 5, 6, 7. Notice the total's going up. 8, 9, 10, 11. Right? Before it refreshes, because it thought its stateful props, its tunneled props, were newer than everything that was coming from the parent. And like I said, that can happen when, say, you're updating the parent, and the parent's time is refreshing, and it might actually have a newer time, but then the props it sends to you have an older timestamp on them because they didn't change. And so you can still figure out which things are right for your particular like rendering. It gets a little hairy to think about, but it's the time thing pretty much straightens it out as long as you put the right time in here. So this should really always be, when you tunnel props, it should always be the basis time, so that you're getting something correct. Now, of course, if I'm sending data that's not true, if that's not actually what's in the app state, then I'm kind of screwing up. So really, right, this should be a get in on the app current state. Of counter ID 1 run through DB to tree, right? That's really what you should be doing here. But I just wanted you to understand that's all the magic there is to it. That when I want to make something on screen that's normally getting props from the database look different than it currently looks, and just refresh that one. There's no root re-rendering here, right? There's if I put a log statement here, right? I do a save and look at the console. I will see there was a root render that happened there. And if I click on these buttons normally with the render I've got installed, there's a root render, the default renderer in Fulcro for ease of use. And it turns out for actual optimization, most apps trying to figure out what to refresh ends up taking as much time as it does for React just to diff the DOM. So it's kind of a waste of complexity and time just to bother in most cases. And so I learned this over much algorithm writing and refining, that the root render is often the win. Or as it's even if it's not a win, it's so close that it's just not worth the effort. But anyway, so these are root renders. But if I go down here and I say, hey, change that to 64, you'll see that no root render. Shoot, I wish I had that where you could have seen it live. Let's clear that because I had those mixed up root renders in there. Change this to 67. Call that. I'm only refreshing that one component on screen. And that's super, super efficient and fast. So if you had a particular structure to your app, and hopefully light bulbs are going on for all sorts of people watching this video, hey, well, why don't I just look through the tables and, right, I could keep the prior app state, the current app state, everything's in tables. I can walk each table, and if the table itself's identical, that's a not equal, that's a reference compare, right? If that one's not equal to that one, then I'll look for stuff in it. But if not equal returns, I'm sorry, equal, identical, sorry. If I look at it and say the old one, is it identical to the new one, and the answer is true, that's a reference compare. It'll be really fast for me to scan all the tables, and then as soon as I find a table, I can do the same thing for the table entries, and I'm done. I can find the 6 idents that need refreshed on screen, get their props, and pepper the refreshes out to the components. And that, in fact, is exactly what ident optimized render does. It tries to look at the diffs in the database to figure out by ident which things have changed. Now the problem is the which things that changed is a little tough when you've got this count, right? This total. Oops, sorry. I have an ultra wide monitor and the video's shrunk on. I double clicked by accident. This total right here that's being updated is only refreshing because I'm doing a root render. If I switch to an ident optimized render, that automatic refresh of total would not be happening. And that's why I no longer have ident optimized render as the default, is it makes it more complex to write your apps. You have to say whenever you do this total sort of thing, oh, all right, well, I did the counter, but when I want to change the counter, I've got to say refresh counters or total or whatever, right? The thing that queries for counters, I have to say, actually, this one would have been updating, right? Because ident optimized render uses this to look through the indexes to find this guy to then re-render it. But then you're doing a root render, so in this particular case, it's kind of pointless. You spend all that time figuring out what to update and then found out you had to update everything anyway. Okay. Did I miss anything here? I think that's largely it. I mean, I could show you really quickly the ident optimized render just to give you the idea. Of like the extra complexity that this adds. So when render gets called, this thing first checks for options. It basically says, well, did the root props change? If the root props changed, I've got to re-render root, and I might as well just do a keyframe root render. Or did you ask me to force a root render, in which case I'm just going to do a root render. If you didn't ask me to do that, then I'm going to render only the stale components, and if that throws an exception, I'll render from root, right? So it's got kind of these backouts. And the render stale components does kind of what I just mentioned. Where does it? I forget where it stores the last version of state. It stores it in the runtime atom. There's a runtime atom in Fulcro that you can just throw namespace keys into anytime you want, right here. The runtime atom, that's the app root. But anyway, you could store an old version of the app. So when we say render stale components, it goes and looks up. Let's see now, what's props to components? Is that the index? Yeah, that's the index. So this guy has a limited refresh option where you can say only refresh, right? You probably have seen that option. If you've sent the only refresh option that says, well, don't even bother figuring it out, just do the stuff I said. And so this goes and tries to figure out which components, gets their ident, and then calls this render component, and render component does the db to tree, figures out the computed from the prior render. So this kind of helps explain computed, actually. That's the other topic that I should touch here. But let me back up. When I pass something as a computed, let's just say x1. The reason you have to do this computed thing is this tunneled props. That's exactly why. It's because the tunneled props won't know what the parent root sent to the component when it rendered it. And so the trick with the computed is it marks this thing as something that needs to be resent as part of the props whenever they get tunneled. So this is sort of a way of separating the two out, right? The plain old props, this factory doesn't know what you might have thrown in the map and what might have come, through the props just as part of query, because this factory is disconnected from the query and ident. Only the component knows that. So this is a way of asking you, the programmer, to mark the extra cruft that you want to pass to this component as, quote, extra props that didn't come in as part of the query, because this tunnel props, this db to tree that I was suggesting here, right? That's how you would compute the props to tunnel to that component. This isn't going to get the computed stuff. This is going to get your callbacks or your whatevers that the parent sent the first time through. And so when you do that targeted refresh, those are missing. And we didn't use computed in here, right? Computed's this kind of third map. Here, we could just show it. So the computed props, why am I not getting my nice render on those? Right, x1. If I did those as associates instead, right, if I wanted to associate on the props x1, here, let's say props and computed props. Right, so I got, how about, what? How could props be null? Oh, computed props is null. Oh, right, because I'm not passing computed right now. So it's telling me there are no computed, but if you look inside of the actual props, x1 is there. Right, so you can pass them that way, and it works just fine. I get the x. It's on these tunneled refreshes. Right, so if I say send 67, do I have my REPL still? Oh, sorry, if I see send 67, do I still have the basis time? What am I messing up here? Did I not get C? Oh, I didn't get C. Okay, I've got C now. Not sure why that's not getting set. There we go. Now it updated. But when it updated and I got the props, shoot. The hot code reload here kind of messes with us. There's 66. If I look at those actual props, I don't get x1 because I didn't send x1 and I didn't know to send x1. But if I do it as computed, then Fulcro internally is written to kind of carry those along. So let me just refresh that, make sure we got it. Okay, so right when I click on this, I get both the computer props and the props. And now if I come down here, I still don't have my C. I don't know why that's not refreshing for me. Oh, I know. When I'm doing the def here on the first mount, the index isn't built until this mount completes, and so starts getting called, but the render hasn't happened, so the index hasn't been built, so C's ending up nil. That explains it. Okay, so let's now tunnel things, and you see when I tunnel things, the computer prop still came through. So that's what computed is about. If you wanted kind of the core understanding of computed, it has to do with this tunneling props, which has to do with optimized render, which requires these indexes. So now you kind of see the full kind of blown picture of how all the secret sauce of optimizing a render. So we can go back to the ident optimized render now and see that's why we're doing this. We're saying look the component up in the index. Once we have the component, then get its prior computed, right? Because that's actually stored on the React component. We actually cache it there, so that when we build the tree, we can reassociate that data tree with the prior computed, so that when we tunnel these props, we get both the computed and the tree. Kind of cool, eh? So really, this render component is a reusable function in this ident optimized render that does all the steps that I told you need to be done. The query needs to be pulled via the state map, and that's because dynamic queries, once you're running, get query with just the component gives you the static query of the component. Get query of the component with the state map can give you the dynamic runtime query of it if it's been changed. We build a query, we run db to tree, we add the computed back in, we tunnel the props. That's literally how you render an individual component in the Fulcro system. And so with ident optimized render, we're just doing some various, find all the dirty tables, find things that are dependent upon an ident. So these are the things that query for, say, the ident in a join. That's a thing you can do in a query. So over here in root, we could actually say, in any of these, right? I could actually say in this component, I want to query for, as a join, counter ID for counter count, so that all the counters know counter ID 4's count. Like, you can literally ask for that. Oops, I wrote the query wrong there. I got the bracket out of place. Right, so you can use that as a join anywhere in the application, as long as the query reaches that component, right? As long as it's the graph is connected. These link-based queries and ident-based queries only get evaluated if the data graph reaches the component in question. So if when you're doing db to tree, we're cut short, there's no edge between root and the counter, well, I don't know if that edge is to one or to many or what it is, so I can't continue with the query. db to tree can't continue parsing the query and filling things in, because again, this is relative, and even when it's a non-relative subcomponent of the query, the whole query is treated as relative. So if you don't reach this relative location, this guy won't resolve. But that's a perfect legal thing to do. I could ask for all of the counters at root. That's what the link query is. Right? So I could find all of the counters, and then I could put the count total on the button of all the buttons, whatever. So anyway, if I embed these, this component now in the index is known as a dependent on the counter of root. If I go and say where in my indexes, let me save that and make sure I think the indexes will get rebuilt on that, and I say find all the things that depend on, I might have to, hot code reload does not rebuild the root indexes. I need to run that guy. Prop to class is counters. Oh, counters. I don't think it rebuilds it. Oh, it does rebuild it. Hot code reload does rebuild it. So you see now that this index now includes, well, the counters themselves. Query for counters, because they've reached back to root and done it. So yeah, you got some interesting side things here. So if you looked at ident optimized render, it's actually fairly complicated to figure things out, because you have to go through everything and figure out, okay, well, who queries directly for an ident, and who reaches back to the root, and etc. In order to figure out what's actually stale on screen. And then you really haven't even gotten the parents, right? You didn't figure out that, oh, that parent just happens to use, that was the example here where we were computing this total. It's perfectly legal for me to use the things that I queried for and compute something from them. This is very common with checkboxes, right? If these four things have checkboxes on them, and I want to check all button in the parent, that check all button is the basically it's lit up if all of its children are checked, right? You don't want to keep that as a separate state. Check all is really a statement of your children, not a statement of yourself. And so this is a very common thing to run into in a React-based or any kind of UI-based thing, where a parent has to know something about their children. Are you checked? What's your current total? That kind of thing. And the ident optimized render, while it technically can be faster, it creates these complexities of when do I have to tell Fulcro how to refresh things, etc. And because there's so much logic in here to compute the difference and figure out what's actually stale, dirty table entries, etc. I mean, this is a study in, how much trouble you can go to not win. And that's the ident optimize render. So this guy is what Fulcro 2 uses. You can turn it on as your render in Fulcro 3 and measure it and see if it wins. In general, I've found that the keyframe render makes it really trivial to write, and React does a fast enough job once you put it in production mode and compile with advanced compilation options that it just doesn't matter. Don't cause yourself the headache. But if you wanted to be a power user and write your own optimized render and tune it up, here's one of the tools you'll be using: Fulcro indexes and tunneling props. So hope you enjoyed the video, and hope it didn't bend your mind too much. Hope you're all jazzed about understanding how these things work, and I hope you find some fun, creative uses for especially kind of this set state thing is probably the most interesting little bit, being able to reach into components kind of by their known identity and sort of give them some instructions through this set state mechanism. Not necessarily the tunnel props. Tunnel props you could really confuse yourself because of this basis time comparison. It really is meant for rendering optimizations. But this set state, you're perfectly allowed to call that as much as you want from anywhere. It doesn't have to be from within the component itself. So this is an interesting way to sort of like look things up by their identity and talk to each other. So you could create all sorts of fun event-based kind of systems in there. And I'm not a huge fan of those for most purposes, but sometimes they're really quite useful. And this is a kind of a nice way to build them.